So let's just go ahead and start off with your background. Maybe tell us a little bit about yourself.
Yeah, so I grew up with Tourette's, so naturally played a lot of video games growing up. I mostly played RuneScape as a kid. Started reverse engineering RuneScape when I was pretty young after they removed the wilderness and ended up creating the largest private server on RuneScape. So this is they're pretty interesting because you sort of host both the client and the server yourself, so you control the entire environment, distribute everything, um, and um, yeah, that grew to, at any given time, maybe like 3,000 to like 5,000 users online. Yeah, this was at the time where you still had to like, manually get hardware in order to host these servers and plug them in. And when you got DDoS, you were screwed. It wasn't as simple as it is, as it is now.
Yep.
And then yeah, after I joined Doctors Without Borders, so worked on Ebola initially because it was specifically on setting up like local networking infrastructure in Ebola treatment centers, and then we ended up building a um, Android-based tablet that you can with like a bunch of OS functionality stripped down for lower energy use that you can dip in polycarbonate with a polycarbonate casing, so you can dip in like a 0.5% chlorine solution, so doctors can do patient triage and not
Mm-hmm.
have to burn the tablets because
Mm-hmm.
anything that goes into these treatment centers had to be burned.
Sure.
And then created a large open source project called MapSwipe, which does
Sure.
like novel data collection
Sure.
for satellite-based mapping initiatives for like war zones and disaster zones, which is primarily used for like public health and disaster response.
Mm-hmm.
Then started a company called Metal, which obviously became a large social network for video games. This is essentially like a low-level recorder paired with the social components where you can share these videos I think we came to the realization that that was sort of a good representation of you know people explicitly capture when these moments are very unique, and so we essentially have like the equivalent of like the episodic memory of simulation when observing tens of billions of hours of gameplay across like tens of thousands of different like games and environments. And so with obviously action labels. And so as a result, we're taking a bet now with general intuition to turn that into foundation models that for environments that require deep spatial temporal reasoning.
Awesome. Okay. Let's go ahead and start off at the very beginning here with what you described as basically RuneScape. So I guess like you started coding pretty early on, like 13, which in Silicon Valley is more common than most people outside Silicon Valley would think. But everybody sort of starts off with different languages and sort of has different trajectories into it. Maybe just tell us a little bit about kind of like how you first got into it. Like, would you say you were more of an infrastructure person, more of an application person? Like, how did your sort
Yeah,
of like your skill set in engineering grow, like from 13 to a few decades later?
yeah. I would say if I had to describe myself, I, I, I trend very infrastructure, low level systems, backend, and systems, and less. I can do things like React and I have like fairly basic modeling skills, but they're I said mostly on the infrastructure side. I um, Starting in reverse engineering, you build a pretty good fundamentals um, view of low level systems and applications, and which obviously comes in very, very helpful when you're trying to create these like very rich data sets of gaming environments. In a way, it's just redoing what I did as a kid. And so, um, yeah, I think like building MMOs, like these are MMOs, right? So they're like many concurrent TCP connections. You can't use like HTTP or like REST protocols. So you had to like these are all like completely stateful servers.
Sure.
Um, and Yeah, so I mean, think of it as like a massive like Java server which has like thousands of different players connected that all need like state updates within like the game tick, and then client that needs to run on like millions of people's computers. So I have a low level systems, and then consumer application specialty, and then now I am I think other than having built some like basic voice models in TensorFlow before the transformer came out. Um, getting more exposed to deep learning and
Mm.
like at
Sure.
scale
Sure.
ML. Yeah.
Awesome. Okay, so sort of given that context that you're more of an infra backend person. I mean, maybe tell us a little bit about some of the challenges that you faced, in your first company, right? Like, I mean, obviously, you are sort of building a social platform. So, I mean,
Mhm.
there's a lot of infrastructure. In fact, I think that might be actually one of the like canonical infrastructure use cases ever in humanity. So, I mean, like, tell us a little bit about that, and then also
Yeah.
just tell us a little bit about that experience. Like, what did you learn building that org?
Yeah, I think the trickiest thing about building capture software and Metal in particular
Sure.
is that if it doesn't work every single time, it you end up like it's like imagine if you took a picture with your iPhone and it didn't work, right? And so building recording software that retains and actually grows, you're actually almost designing for defaults at the OS and GPU driver level, and user error, which is actually like the most common. And so the most other than the fact that just like good low level capture is integrating with all the GPUs and then syncing audio and video at like a place where it doesn't lead to FPS drops is fairly difficult. Like other than that is just actually reliability where we spend most of our time. So like for instance, Metal isn't actually a single recorder. Metal is it has multiple fallbacks. Like it starts with it tries to inject into the game. Then if the injection doesn't work, it falls back on like window capture. If window capture doesn't work, it falls back on screen capture, and then we run this like cutting tool that finds like the bounding boxes of the window and makes it look like so. There's all these different APIs that you have to sort of capture, and that leads to a very very good experience. And so that's on the front end. On the back end side, right? So as I mentioned, we have roughly as many video uploads as YouTube. Now, apples to apples, that's on uploads. That's not necessarily on hours, right? So in terms of data volume, I don't know the exact difference. I don't know if that's public for YouTube either. There's about 800 million videos a day. People capture roughly 6 million videos a day currently on Metal. Sorry, I said 800 million a year. And so there's a few interesting challenges about that. So I also, for instance, I wrote our first transcoder stack, which was our first transcoder stack ran on NVIDIA GPUs. It had those session limits, so I had to apply these CUDA patches to get the session limits removed, so I can do like more concurrent FFmpeg sessions on the GPU. So yeah, so all these like things you have to do like large scale, fast, real time transcode to give people like a great experience was quite interesting. Databases at this scale can be pretty interesting as well. And so I think like, if we have any downtime nowadays, it's mostly related to specific slowness in like specific parts of the database that then trickles down into the system. And those are the trickiest ones. I will admit that I found scaling services that can use things like REST much easier than live TCP connections, where it was a custom protocol. It was like a custom RuneScape protocol that everybody used. Um, uh, it's just a very different. Like you can use standardized infrastructure, whereas with running game servers you can't.
Yeah.
Like you're programming packets with opcodes and contents, and if people flood you with similar packets, then you have to do things like deep packet inspection or to actually filter these things out. And I literally had to go and buy Fortinet hardware in order to get enough bandwidth in order to even get to a point where I could filter DDoS attacks, for instance, right? If you're using HTTP and REST, you can just put it behind a reverse proxy and you're done, right? And so the infrastructure challenges are quite different. Now, it's interesting because with general intuition, it will be more like the game server because we're going to have these like real-time connections to all these agents out in the world, right? So it's going to be an interesting redo of that infrastructure challenge in a way. Yeah, I'm excited. Yeah, so going into it, it's in many ways just redoing what we did.
Awesome. All right, let's get to a very, very, very exciting general intuition. Okay,
Yeah.
$133.7 million seed round. Quite massive, right? So there's a very big, massive goal that you guys are tackling. And it can be described in a lot of different ways, right? I think the website describes it as, I quote verbatim, like frontier research lab dedicated to games in the real world. Now, that's
Yeah.
pretty broad. Well, there are a lot of things that are frontier research labs. And while the real world is the real world, so that's a lot of things. Games is a little bit more specific, but still there's a lot of different types of games. So if you had to describe this, the mission of your company in one sentence in a way that's more specific, as concise and thorough as possible, what would you say?
Betting on the gaming action space, i.e., controllers,
Mm-hmm.
to be a universal interface for input transfer into systems into any environment, including physical environments.
Mm-hmm.
It's really, and I think that's a big difference. Is people kind of mistake us for working on like humanoid robots, and
Sure.
that's not the case, right?
Sure.
So we work on specifically the any system that has a gaming input device that and then again, the bet for us is not necessarily that we can nail physical environments out of the box.
Sure.
The bet is very much that with our data volume, we
Sure.
know we can win simulation, gaming environment simulation, because
Sure.
that's already where a lot of data sits. And then the bet is that with the amount of environments and for instance, the amount of physics engines represented in the data, the amount and the fact that physics engines are also getting better every year. And also the fact that we can actually just go collect like real world data,
Sure.
right? That with this many examples and this many environments, that we can transfer to novel environments with the same action space.
Sure.
That's the key part. Much quicker than others. So you could kind of describe us, it's another sort of one-liner that I use, is we're essentially taking the equivalent of the LLM bet from web pages, except like Metal is essentially the common crawl equivalent with
Sure.
like ground truth actions, right? So we're essentially just taking the LLM bet for spatial temporal reasoning. Yeah, so that summarizes the research pretty well, I think.
Okay, awesome. So I mean, let's maybe break this down a little bit. So, you guys are a business, right? So ultimately, you have to sell to enterprises, or you have to sell to customers, people that want to get some sort of utility, right?
Yeah.
And so like I think it's still a little bit unclear, like what exact applications people are gonna have. I'm sure that there's a lot, right? Maybe elucidate to
Yeah.
us like 5 to 10 of the top in descending order, like applications by usage and volume you expect General Intuition to have in the next 3 to 5 years.
Descending order. Okay. So I'll name them first, and then I'll try to sort.
Sure, let's do it.
So the area that we're really focused on right now is search and rescue for drones, and the reason we picked drones is because drones account for physics transfer to a large degree on the flight controller and the motor. So actually, they ship with game controllers.
Sure.
Uh, the second is game bots. So
Sure.
we're working with game publishers to create bots for all sorts of types of video games that behave more like humans. Um, a bit of an interesting one, but like for instance, robotic arms ship with game controllers, right? And so like I think as long as the devices have a like similar DOF to the types that are represented in our data, the bet is that we can nail those. There's also lots of non-gaming applications for simulation, right? So training, for instance, manufacturing, like all sorts of these. And then I think one interesting area that we are exploring, for instance, is negative event prediction for adverse events. So, can we predict that an adverse event will happen when you're, for instance, flying a drone or a truck, because there's so much representation in the data of these types of events.
Sure.
So I think this sort of describes it pretty well. I would describe our bet as a straight shot at a general approach,
Sure.
and then finding kind of transfer to new environments from there, as opposed to solving for 5 individual use cases.
Sure.
We're really only splitting by 2, which is simulation and non-simulation, and the reason why we do this is for safety reasons, right? So you want to have a more constrained action space in the real world than you do in simulation. And so really, from a go-to-market perspective, that's how we look at it.
Cool. So let's say tomorrow
and-
you have an enterprise that is trying to trying to do this drone use case. Maybe just tell us a little bit about kind of like how you guys would go about convincing them. So obviously you have this massive data set of simulations and all of this other stuff. Like what exactly would you say that would make you competitively differentiate from like a Scale AI or a Turing or something else where they're
Yeah,
collecting a lot of data?
You'd
Yeah.
be surprised how much the problem in drones, for instance, is
Sure.
still just build things that don't stupidly run into other things.
Sure.
So I think the representation of adverse events and crashes and things, we have a massive moat.
Sure. Sure.
And so that's one. Two, the models that I just showed you, for instance, they're
Sure.
tiny.
Sure.
They're very small.
Sure.
And so if you are in an environment with like low cell phone reception
Sure.
or signal,
Yeah.
then
Edge devices.
they'll work, presumably.
Mm-hmm.
And then I think for the other thing to think about it is one of the so the models that we're building, right?
Yeah.
The any system,
Yeah.
like for instance a KBM action space, right?
Sure,
Keyboard
sure.
and mouse.
Yeah.
It's quite a high DOF. It's not as high as like a highly dexterous humanoid robot, right?
Sure.
But it's quite high.
Sure.
And so I think that the we're starting with drones, like that's why it's called general intuition.
Right.
It might be the case that you can like write an adapter for instance, a
Sure.
humanoid robot to
Sure.
take basic control.
Sure.
If you're in like unseen environments, for
Sure.
instance, right? And so the bet that we're taking is not necessarily that we want to deliver this like end-to-end solution to physical environments. It's
Sure.
really that we have this base sort of general intuition layer.
Sure.
And our goal is very much again like the LLMs, like one of the things that we're thinking about, for
Yeah.
instance, can we try to predict maybe a second or so ahead of time
Sure.
of what and then so if you want to calculate your own predictions
Sure.
for those, with a hypernetwork
Yeah.
or some other form, then you can just do that, right?
Mm-hmm.
And so again, these are quite speculative. We don't
Yeah.
know if these will work, but just so you think of how we're thinking, like we're
Yeah.
thinking of this as a general layer.
Yeah, for sure. I mean, I think kind of like one resounding theme, and obviously this is sort of like branched off of games, is this concept of like multimodal, which is like pretty key to what you guys are doing, right? Not only the fact that you guys have these sort of videos, but also like you guys are thinking very critically about multimodal web agents. So this is a pretty explosive space, especially in the past 5 years. Right, we see things like Visual Web Arena, so on and so forth. There's been a ton of papers across a lot of top AI conferences that have been working on this. Like my understanding right now is basically like you guys have a lot of this data, you have a lot of the simulations, game data. The goal is to maybe train some model that is maybe generalizing that data to other different real world use cases. Maybe give us more detail if that summary is not deep enough, right? Because like quite
Yeah.
frankly, right, like I'm sure that you guys have this moat, right? Because you have a lot of this gaming data, used to be with Metal, you have all of this. Like aside from that, I'm sure that there's like other secret sauces that are hidden that you guys have. Tell us a little bit more about some of the other secret sauces. Like, what is it about you guys that you feel like to the extent you're able to say, like, is categorically different aside from the data?
So I don't think for instance, there's not many people who are considered top researchers in
Sure.
world modeling.
Sure, 100%.
And,
It's also a very new
we
field.
We have 4 of them.
Yeah.
Who are all
So technical
who are all
talent density.
excellent.
Yeah.
I'm obviously not one of those.
Oh, that's fine. That's fine. That's fine.
But
you lead them. You
hopefully
lead
one
them.
day.
You lead them. Yeah.
And I think for us, this has never been done before at this scale, right?
Sure.
And so like a big lesson from LLMs, right, is data and scaling data and compute against these types of data sets just have really, really interesting emerging behaviors, right?
Yeah.
And so really the answer is that we're going to get to do research in both world modeling and policy learning that have just never been done before at a like a ground truth data scale, where like look at, for instance, if you had to do manual action labels, right?
Yeah.
The amount of error that accumulates
Yeah.
on both inferring actions from video and
Yep.
and from human labeling is too much,
100%.
right? And so
100%.
the type of research that we're doing at this scale, like I said, we do about 800 million of these video uploads per year.
Yeah.
It's just never been done. And
Yeah.
and one interesting example, for instance, is like, so that is compared to YouTube.
Yeah.
YouTube has a lot of spam, but like for
Yeah,
instance,
yeah.
you still need to solve for like pose estimation on
Yeah,
YouTube.
yeah,
Whereas if
yeah.
when you're playing video games with Metal, we don't need to solve for this.
Yeah, yeah.
Because you're already sort of in perception of
Sure.
the screen, right?
Sure.
And so the data set the data set is truly unparalleled.
Yeah.
There's nothing like it.
Yeah.
And
Which is incredible, by the way. Truly incredible.
and and you'd be surprised how many sort of very realistic environments exist,
Yeah,
right?
yeah. Those graphic
In
designers are working overtime, man. Those graphic
Yeah,
designers.
yeah, and the physics engines are getting better. And
Yeah,
so I also think
impressive.
a lot of the learnings from like, the 2015, 2016 era, they
Yeah,
don't actually hold, like a lot of people quote that as like that's the reason it won't work. Like
sure.
two reasons. Like one is the actual game sample size that those things were tried on were tiny, like
Yeah,
sub 50, and we're at two orders of magnitude,
yeah,
right?
yeah, yeah, yeah.
And then just on the environments, and that's not even considering for environments inside environments,
Sure,
right?
sure,
Which
sure,
are
sure,
like
sure.
Roblox and GTA
Sure,
5 and
sure.
things like that.
Yeah,
And then the second thing is that the physics engines and graphics were just not as developed, right?
yep.
And the GPUs have even on the consumer side
Of
have
course,
gotten much better.
of course.
And so um, yeah, I think for us, and it's also you have to not look. I think a lot of researchers tend to have this view of um, the end-to-end solution is the best solution, right? And I think for us, we don't really like we look at the gaming input device as the area of focus. If
Yeah,
we don't like if we can't, right? And if we can't control a highly dexterous, robotic hand, that's fine,
yeah,
right? The bottleneck is that general that general layer of intuition, and so and we just fundamentally don't believe that like text is the method, because text is fundamentally like a very compressed representation of reality, where actually you lose usually this spatial temporal aspect, right? And
yeah,
so I think for us the bet is that we build these foundation models that are very very great
yeah.
tasks that include deep spatial temporal reasoning, and then we you figure out things like text conditioning and things like that.
Yeah. Awesome. Okay.
Yep.
All right. Let's get cracking into some of the more deep technical things. So, more broadly speaking, right? There's like sort of three areas that you guys care about, right? Agents, world models, video understanding, or at least that's sort of my
Yes.
understanding, right?
Yep.
Let's start with agents. Okay, and everybody and their mom is talking about agents these days, right? So like, categorically, you guys are talking about deep spatial and temporal reasoning. That's still pretty broad, right? So like,
Yeah.
let's like go like a few levels deeper into this. What specific technical problems within agents, to the extent that you're able to talk about, are you excited about right now?
Yeah, so let's limit it also to again
Sure,
game controller
sure, sure,
and KVM input space,
sure.
and then let's also limit it to actions that are only represented in gaming,
Sure,
right? And
sure, sure, sure,
so
sure. Yeah,
right, like moving a finger is like unlikely to be represented in that, but
exactly. Yeah,
navigation is very represented,
yeah,
right?
100%.
Um, let's see. So the research focus right now is very much on navigation,
Yeah,
specifically for physical transfer because it is so
yeah,
represented.
yeah.
And it is again this like general navigation
Yep,
backwind is just a very real problem.
sure.
Especially because of the representation of adverse events, we think that this is just a very good place to start.
Yep,
And then, so very narrow action space
sure.
for the research on physical devices, and then in simulation, it's very broad, right?
Okay,
So,
yeah,
simulation, right? Like you want if you have a bot in a specific game, you want them to be able to shoot a gun. Whereas in
sure,
because we control the entire training stack
sure,
or the entire data stack end to end, right? We can
sure.
sort of guarantee that if a model is trained for a physical environment, that it doesn't have a representation of that action.
Sure.
And so, yeah, I guess this is kind of how we think about it.
Yeah.
The other thing is the models need to be able to run in real time. These tend to be small models. Yeah, we have like small transformer-based models essentially that take that take frames and they predict actions, right?
Sure.
And they predict those actions in sort of a computer use or game controller space.
Sure, sure. Okay, awesome. Let's get into part two here, world models. Okay, so
Yeah.
another huge term. I think maybe this is like slightly less familiar to people who are still stuck a few years ago. Maybe like for the audience that might not know a lot about it. Maybe briefly talk a little bit about kind of like what a world model is, and then
Yeah.
for maybe the audience that knows a lot more and like does their PhD in world models, tell them about like why exactly you guys are different than everybody else that's working on this.
Yeah. Um, it's hard to even just describe what a world model is given
Yeah,
how many
yeah, it is,
definitions
it is.
exist. But
I mean,
I'm
you
going
can
to
you can also just skip that question. We can let the
yeah
audience just do their
well
research.
maybe I'll talk a
Yeah,
little bit about why we are excited about them.
sure,
And so for us, kind of the video understanding and world model direction are very, very similar, right?
sure.
It's our bet on actually having environments that have like actual physics represented,
Yep.
right? And so because games, obviously, to your point, right? They don't have as many like real physics environments, and
Yeah,
so
they don't.
right, and so we need to solve for this, and the
Yeah,
bet for this is to take, for instance, video models
sure,
and bet on maybe being able to generate sequences and then action label those, right?
sure.
Or maybe take videos from the internet and be able to have such a good video understanding that you can action label those and bet on direct transfer from video,
Mm-hmm.
and have a training set that maybe represents both,
Sure.
right? So both real world video and gaming video,
Yeah.
and then increasingly, if you have like very, very good, for instance, models that
Sure.
that understand these actions in physical environments, maybe you can start leading more towards the real world video side.
Sure.
And so from the world model perspective, world models is really for us accounting for novel environments that because the bet is agents, right? And so we build world models in service of,
Sure.
of agents,
Sure.
or policy learning, right? So and same for video understanding. We built those in service of the policies. So it's really about generating new experiences that are not represented in the data but are important, like failure cases, right?
Mm-hmm.
And so what a world model is essentially a usually starts with some video model that you then fine tune or train from scratch to have sort of representations between observations and actions, which is where the model learns to be able to essentially predict the next frame from the first frame.
Yep.
And so another way to think about it is you are you start with a frame, and then you continue to predict the geometry and interactions in that environment.
Sure.
And when you do that, well at scale, and then, for instance, in Genie 3's case, what's really, really interesting is it also had event conditioning, which is where they were essentially able to prompt for specific events to happen in the world model, which is really interesting, right? Because it's how you can like increase like the stochasticity and things like that of events that are represented in the training set. So look at this as essentially being able to generate novel experiences that your agent can explore, that where it's predicting frames just from the actions of the agent, and because the model has such a good understanding of the world that it's modeling, it's able to correctly predict the continued interactions and geometry of the world based on just the sort of the your action inputs. It's fascinating.
Okay.
It's an absolutely fascinating line of research, and the fact that it works is just mind blowing to me.
Mm-hmm. Awesome. Yeah. Okay. All right. Really quickly here, let's get through video understanding, right? So the focus here is transferring beyond games. We already talked a little bit about like some of the applications that you're interested in transferring. Maybe tell us a little bit about some like the important technical challenges of actually transferring it beyond games. Like obviously, right? Like there's certain movements that are not going to be captured in games that would maybe be captured in the real world. Like first of all, like what are those movements? Like I think I think we went over one super briefly, like finger movement, things like that. I'm sure there's a lot more, and I'm sure this is something that you think a lot about, right? So like tell us what your limitations are. What are the limitations of transferring?
Yeah. So again, this process sits in two stages. Like first, we care the most about transfer from video on where the gaming action space is represented, right? Sure. So a drone flying through a scene on YouTube, right?
Sure.
And so we care less about having learning the action space itself from video. I think that's more just of a go collect the data, right? Or go, do teleoperation and
sure.
and go then so it's more for us about the bet on more environments,
Okay.
right? Than it is on the action spaces. And then from a world model perspective, is I think there's kind of like we have two bets. Like one is simulation, and one is the world model. And to be clear, like world modeling for us is still like it's very much still a research question, right? It's
Sure.
actually like it's not super clear yet
Sure.
whether you can train these agents inside world models at scale and how it compares to the policy learning and the like for instance, the VBT paper describes as well this technique called inverse dynamics, for instance.
Yep.
And so these things are so world modeling for us is a bet. I can't definitively tell you, it's going to go this way or another. But it's a bet on environments that have the action space represented, and then observing interactions that are in the physical world, right? Like you'll never come across chopping a tomato in a video game,
Sure.
At a large enough scale,
Sure.
right? I think little other things like camera shakes, like how cameras actually perceive in real worlds compared to video games are quite different. So I would say that one's quite interesting. Then the amount of cameras, for instance, like you really rarely have a game that has like multiple cameras that you're then inputting against, whereas like
Sure.
humanoid robots have multiple.
Yep. Yep.
Cars have multiple.
Yep.
Right. So I would say this is like a pretty interesting limitation.
Sure.
Yeah. Did I cover enough so far?
That's all.
Okay.
What do you think about lighting?
Yeah.
Is lighting a limitation or no? Kind of,
So,
but not really. Are the graphic designers good now?
To be honest with you, it's unclear.
Yeah. Okay.
Why
is it unclear?
So again, the bet that we're making is that similar to an LLM,
Sure.
right? Where when a new base model comes out,
Sure.
you need again less data to fine tune or transfer to like a novel environment,
Sure.
because the base models are just more capable.
Sure.
And so the bet is that this so the bet is that if we have enough, for instance, input devices represented, like for instance, Metal has more people with steering wheels than Waymo has cars on the road.
Sure.
Like interesting random facts. So like I think the bet is that this eventually applies to both new actions and new environments, but it starts with just new environments.
Cool.
So so that's the bet, is observe interactions that are critical, also from a safety perspective, right?
Yeah.
And aren't represented in video games as much.
Cool. All right, let's get back up for a breath of fresh air before we get way deeper into some of the technical details and start hammering away on some research papers. All right, you go into a time capsule. You come out 10 years later, okay? And in this alternate universe, right? There's Pim de Witte right now that is on the podcast that is still running General Intuition. Now this company does like insanely well, right? We're talking like miles and miles better than the next biggest company on the planet. And so now you're coming back from this time capsule. 10 years have passed. Like, what is your win condition? What is your belief that like we have won, right? So like, it's hard to say what OpenAI's win condition is, right? And it's hard to say what Anthropic's win condition is, but like, what is your North Star? Like, what is winning? What is success to you? And maybe outline like 2 milestones. Like milestone 1, like incredible, and like milestone 2, this is like insane.
Yeah. So milestone 1 is unblock, create a general backbone for spatial temporal reasoning so fast that the hardware supply chains converge on gaming inputs as opposed to the other way around.
Mm-hmm.
We think this is the bottleneck, and we think that if we essentially solve it fast enough, then you'll see the designs actually adapted to new systems.
Yep.
That actually just represent gaming inputs.
Yep.
Like life imitates art in a way.
Yeah.
And so that's one. The second is what I would love to see is actually see transfer on both new action spaces and new input devices as well as environments, right?
Sure.
So if it turns out that we also need a lot less data to connect like a highly dexterous humanoid hand or like torque control on a motor, right? Like these types of things would blow my mind. Where essentially, you can sort of pre-train on these like large amounts of games and these gaming access spaces, and then turn that into like a real mode also for where you need to do less physical data collection, right?
Sure.
That is from a technical perspective. The things that if these things happen, I will be mind blown.
Okay.
I think from a company perspective is so the name of the company is actually after Demis Asada's quote from Foldit. So he said once, "Wouldn't it be amazing if we can mimic the intuition of these gamers, who, by the way, are only amateur biologists?" And that was sort of the initiation of AlphaFold. So from a company perspective, the things that I would love if spatial temporal reasoning, like a general interface for it, also transfers to applications in science.
That would be great. That would be great.
Yeah. So that would be my dream.
Yes. Let us pray that happens. Let us pray.
Yeah.
Okay. Awesome. Okay. Let's hammer away at the papers. Okay, for the audience, this is probably going to be the most technical part and also the fastest. So if you can't keep up with some of these, just like check out the papers on your own time. All right, let's start with the first one: scaling instructable agents across many simulated worlds. Maybe just tell us a little bit about. I'm sure the audience can read the paper on their own time. Whatever from this paper you feel like has actually helped you guys concretely in your day-to-day in solving these problems.
Yeah, so this one is really interesting because it hinted at the ability to generalize novel environments in gaming data, and I believe it was specifically for they specifically used a navigation action space for this. And I believe what they did is they basically had a 9-1 holdout where they basically trained an agent on 9 games. They had one holdout game. And then the holdout, the agent that was only trained on the holdout game performed roughly as well when it came to navigation as the agent trained not on the holdout game but on the 9 other games. And so this to me was for the first hints that a bet like this was possible. There's also a really interesting section on the paper and where you can sort of see the actions that are actually represented in these games, and you can see I don't know, am I allowed to pull things up through screen share and stuff like that, or was that not gonna work?
We probably don't have the time for that, but just go ahead.
Okay, no worries. But you can see in this paper, you can there's a circle diagram of which games have which action spaces represented, and specifically the ones that transfer over to real world environments, which is fascinating. I think this paper just lays out the potential of the bet really, really well. Do you want to keep going on this one, or do you want to go
Let's just like run through them. Second one, agents play thousands of 3D video games out of Tencent. So I mean, this obviously sounds like incredibly relevant, right? Like what do you think is like maybe one key takeaway from this paper that actually helped you guys?
So this one I found interesting because it predicts these actions in code space, and like for instance, this one gave me the idea to let's predict maybe a little bit ahead, and what this does is it actually predicts behavioral trees in code space. So from a this is mostly just fascinating for me from a design perspective, right? Because if you were able to predict the actions that you are likely going to predict in code space, it might help with things like safety, right? And I think so this is one. The idea of using, so for instance, behavioral trees for those predictions, also fascinating. Because it introduces almost like a little bit of determinism in the behavior that like you otherwise wouldn't have, right? So I think for me, this paper was just, it was mostly creative inspiration, but I think fascinating as well that they were able to make this work.
Awesome. All right, next up, Pi Zero. Text-based versus ground truth action labels. Maybe just tell us a little bit about this. For people who are not familiar with Pi Zero, it is a research paper that was pretty big. There's a company called Physical Intelligence that does a lot of really, really great stuff. They wrote this paper. They are incredible. Definitely go check them out if you haven't. Tell us a little bit more.
Yeah, few interesting things here. So one, I think this really shows that I believe they use Gemma, but this like really shows that with a VLM base, you're able to sort of turn a VLM into an action prediction model, right?
Yep.
And I think and so this was interesting, thinking through how do you actually construct the training data for these types of models, and like do you start with something like Gemma or Polygemma, or do you just go straight for pre-training? Do you start with a vision base? Do you start with a VLM base? Do you try to fine-tune models first on the data, and then so I think this for us gave a really interesting just confidence boost in the fact that we could start with, for instance, a VLM base if we wanted to. We didn't end up going this route, but I think and then they sort of used that as sort of the backbone for generalization, and I think they were really like one of the first to really show us that this worked, which I think was fascinating.
Awesome. Okay, next
Yeah.
up, VO3 paper, specifically titled Video Models Are Zero-Shot Learners and Reasoners. All right, this one is a huge paper. There's a lot going on here, but like maybe whatever you think is relevant to directly what you guys are working on.
Yeah, to me, the main thing that's fascinating is just the detail at which these models seem to understand like fluid dynamics, and not fundamentally, but in a way that is represented in the videos, right?
Sure.
And so this is important for us because simulation is really computationally heavy, and so gave me a lot of confidence that we can sort of bet on video transfer in order to deeply understand the physical world, especially
Sure.
if you can start generating some of these videos, right?
Sure.
And so I think for there's many more things to be said about the VO3 paper, but I think everybody here has probably read it. There's just like I do really sort of consider it the like the GPT-2 paper of kind of the of video models, or of like sort of spatial temporal reasoning, and I think the exciting times to come.
Yeah, awesome. Okay, all right. Last research thing we'll get into before we get into a more general discussion here. So, physics engines versus world models, in particular, like looking at things like Genie 3. Maybe tell us a little bit about kind of your thoughts there.
Yeah. So I went into it a little bit, but I think you really like there. For instance, there are even environments, and again, my dream being that these are applicable for science. Like there isn't a lot of video representation of like a cell.
Indeed.
And you can't fully simulate it as well
Quite
today.
Difficult. Quite difficult.
Right. And so it's super difficult, right? But just I'm just directionally kind of talking about how I think these things will play out.
Yeah.
So I think you're always going to need some form of simulation.
Sure.
That is backed by a physics engine of some sort.
Sure.
And you're also going to need world models that are they're going to perform much better when there's lots of video.
Sure.
And so I think and then I think also the interesting thing about video models, right, is and world models is that you're not in verifiable domain, and so if you're training agents, especially if you're trying to understand how they are performing in a benchmark way, like it's quite difficult to benchmark these things when they are in outside of verifiable domain, and so hill climbing is just harder. So I think that you need both. I think you will always need both. The thing that's kind of fascinating to me is like, for instance, in physics, so when you're working on, like, for instance, let's say Isaac Sim or something like that, right? Or Newton. These are differentiable, which means that you can you can learn from the generations of the environment, and right. Like you need those to compute the gradients. So in a world model, this is currently not the case, right? So you're completely incapable of understanding sort of why this generation was generated and whether or not it was correct.
Sure.
And so to me, it seems like you want to be in verifiable domain for as much as you can. And so I'm very excited to bet on the simulation and the engine route, but I'm also really excited to see what type of data you can generate inside these world models and how they contribute to the performance of the agents, right? And so also it is really difficult to uh, like the compute complexity of environments goes up quite quickly as you add new agents in a deterministic simulation, right? So how like this is why it's so hard to create NPCs that behave like humans, because like human behavior is like extremely hard to simulate, right? And so um, there are these things where you just have to bet on video transfer, and then there are these things where you just like, for instance, I also like locomotion and things like this, where whereas I think you can just bet on sim and RL. And so the thing that fascinates me is I don't think it's going to be one or the other. I think it's sort of going to be pick the right things from the tools that are available and learn how each of these affect the performance. And I think games, like, specifically games, I suspect will be less impacted by world models and more just like a big bet on like hooking up LLMs to game engines, and then generating data for training for agents. I think that will be the primary customer for world models.
Okay, awesome. All right, we're gonna end with two last questions here, and I'll just list them out in advance to save us time. First question is going to be, what are the other big areas that need to be solved? Clearly AI for science, right? And clearly some of the work you guys are doing. But there's other big areas. Isomorphic labs, right, is doing some cool stuff. Periodic labs, I'm sure you know quite well, doing some cool stuff. What are some of the other areas? Maybe not company names, but like areas of interest that you think are like, wow, like these are big, bold bets. Just like our big, bold bet here at General Intuition. Number two.
I mean, physical intelligence has to be named here, right?
Like, of course.
I think this is. I think. Man, there's so many here that I could name. I am personally the most interested in the science applications. So physics-inspired neural networks, PINs, goodness. I'm really interested to see where these go and what you can create. I also think that somebody needs to really do a good job collecting all the like science observational data from all the papers in a way that is like more accessible. For instance, such that you making these models becomes a lot easier, or you can where you can actually simulate things in PyTorch and again learn from run those against like a bunch of observational tests and then hopefully learn from those generations, assuming that the tests are they pass, right? And so this, to me, building really, really good simulations backed by real observational data is that to me is a fascinating area of research. Let's see.
Anything outside of that area, because that's kind of like your area, right? Like imagine that. Imagine you never cared about that. Like what are the other big problems that you're like, wow, they have some guts to like actually solve this? Not another B2B SaaS AI, startup, right? Like something that's like actually solving like a really key big research problem. Like what are the research problems that you're excited about?
Maybe companies like Helsing, for instance, who are trying to who are focused on the fence. And trying to produce agents that defend democracy. I think this is an area that I care deeply about. That's a difficult problem, right? Like for instance, F-16 like doesn't really use vision data. Like that's almost entirely based on sensors. That to me is a super bold bet. So actually, it's kind of, this one's interesting because it's like the inverse of our bet, right? In a way, where it's like a bet on like highly specialized like sensor data applications.
No, that's good. That's good. I think it's plenty for the audience to think about. Certainly. Okay. All right. And very last question here. Our audience, intentionally so, is quite powerful. Some of like I would like to think, and I'm sure the audience is listening. Some of the world's best PhD students, engineers, researchers, really in the world, right? So this is not just the U.S. It's not just Canada, whatever. It's the entire world. What message do you want to leave them with? You guys are very intentional about scaling your team. You want to grow it to be incredibly talent dense people slowly, sustainably, instead of just adding a bunch of people for the sake of doing that. You guys have raised a lot of money, but you guys are
Yeah.
being very careful with the way that you guys use it. And you don't just want to hire a
Yeah.
bunch of people for the sake of hiring a bunch of people. So, if somebody is in the audience and they work on world model research, they think this is super interesting, super exciting, how should they engage? And then also, like, how should they self-select out? Like, what are the characteristics that you're looking for? Like, do you want
Yeah.
people that are high agency? Like what exactly do you want people who join you to self-select into?
Yeah. So the reasons why the team is exciting is two things. One, so we genuinely get to take a straight shot at this, and so for a few reasons. One, like the core business that General Intuition absorbed metal is already profitable, which means that we don't need to invent products on the way. We can take
Sure.
a straight shot at sort of at general embodied agents.
Sure.
And the second is we generally have some of the best world modeling researchers. Anthony who led research at Wave on Gaia 2, Vincent Micheli, Ilwan Alonso, and Adam Jali, who did the Diamond paper. And so we're really looking for people who have some demonstrated excellence in this area of research. And and then we really aim to, like, set you free and pursue your ideas. And and I think how to get in touch. I think I'm pretty active on Twitter. It's also just my first name, so Pim at generalintuition.com is a good place to reach me. The characteristics, I think self-starter is really important. I think it's a small team, so really having experience doing your own research and without requiring too much supervision from others is quite important. I think a lot of the reason why the team is here is because maybe some of them were managing people before and they wanted to get closer to just doing the work. And so I think if that excites you, like, we're a team of just bunch of, like, fairly technical ICs and engineers who are taking a straight shot at this without a lot of the bureaucracy and politics. And I think we obviously have lots of compute now. So if that excites you, yeah, I encourage you to reach out, and I very much look forward to it.
And where are your offices?
New York and Geneva.
Okay.
At the moment, and we're looking at opening in London and San Francisco.
Yeah, definitely open one in San Francisco. I mean, that's that's a whole
we
number.
we likely will. It's mostly about finding just a really good group there.
Yeah, 100%. Yeah.
So.
We may or may not be biasing as how Delta's headquartered in SF, but yeah.
Yeah.
All right, awesome. Cool. Well, Pim,
Good.
Truly
Good
incredible, truly incredible. We are so happy that you took the time to come on the podcast.
Yeah.
And yeah, I mean, I hope this was a fun discussion. We definitely tried to keep it as technical as possible and as brutally honest as possible. And as little fluff as possible. But thanks so much for coming on. Really appreciate your time.
Yeah, likewise. Have a good one.